out of 2.3. And on these, remember we have that flow chart. And when we work these out, it's going to tell us how we want our answer presented. Do we want it in standard form, or do we want it in slope-intercept form? So let's go ahead now and begin with question 3. And this is out of 2.3. We're going to look at question 3. Now on this one, they want you to find the slope and the y-intercept. So we have a minus 5x plus 2y equals 1. And we want the slope and the y-intercept. Okay, so that's what we're going to try to find. We're going to try to find the slope and the y-intercept there. Let me adjust that focus a little more. Okay, so what do we need to do? Well, we want the slope and we want the y-intercept. So don't we have the point or the slope-intercept form, right? That's got the name slope-intercept in it. That's what we want. So let's go ahead and solve this for y. So I'm going to move that 5x over. And that leaves you then with 2y equals now 5x plus 1. Then we'll divide by our 2 everywhere. And now we've got our equation in what's called slope-intercept form. And that is 5/2 x plus 1/2 there. So that's what we've got. Now, what do we want? We want the slope and we want the y-intercept. Now, the main thing we need to remember about the y-intercept is the y-intercept is going to be a point. Not just one number, it's an ordered pair. So your slope is the number in front of the x. And that's your m, and that's 5/2 there. The y-intercept is an ordered pair. It's not just that 1/2, it's going to be 0, 1/2, right? You need to make sure that, let me adjust the focus a little bit more. Try to get it as best as I can. I think that's a little bit better. Okay, it looks a little clearer there. So when you write your y-intercept, you want to make sure that it's 0, b, and that b is that number on the end there. So there's your slope, and there is your y-intercept. And that's what they wanted on question number 3. Question number 5 is next. And question number 5, we want to write the equation in standard form. I'm not going to work this one completely out, but I'm going to get it to the point to where it's in the point slope form, and you can get it in standard form from there. So I'm going to do all the work except for that last couple of steps. So we're going to look here at question 5. Okay. And let's see. Lacey, isn't it? Yep. Okay. So we're going to look at question 5, and we've got these ordered pairs. We've got the point 6 minus 9, and we've got minus 5, positive 9. Now, when we look at this question, we need to think about what we've got, because remember, we have 3 different scenarios. We have when you have a point and a slope. We have one when you have 2 points, and we have one when you have a point and a line equation. What are we working with? We are working with 2 points. So we go to our flow chart. We go to our second page. So we want to find the equation of a line when you have 2 different points. We follow it verbatim. You can use this on your exam. And what do? We find our slope. So that's our first step. We label x1, y1, x2, y2. And then we find the slope. And that is m equals y1 minus y2 over x1 minus your x2. And then we fill it in. So that's going to be minus 9 minus another 9 over 6 minus a minus 5. So be very, very careful with those double negatives. That's where students make a mistake. Okay. Most commonly made mistake is at the very beginning. Sign errors, simple arithmetic errors, things like that. Take your time. Be very careful with these because it's all just algebra and arithmetic. So what do we know down here? Well, the double negative here is going to make that positive. And up at the top we have minus 9 minus another 9. So that makes it a minus 18. And 6 and 5, that makes it an 11. So our slope is a minus 18 over 11. Now, once we have that, what do we do next? Okay, we just found our slope. Now we use our point slope formula. So now we use point slope. And we're going to use m equals minus 18 over 11. That's my slope. And we can use either point. It doesn't matter. So I'm going to use the 6 common negative 9. And that's again going to be x1 and y1. And our point slope formula is y minus y1 equals m times x minus x1. I always think it's very, very important that you take the time to write the formula down. That way you got it, that way you can see it, that way all the parts go in the right places. Now we fill it in. So that's going to be y minus, watch your signs there, a minus 9, so that's another double negative. And that's going to then equal a minus 18 over 11 times x minus 6. I'll do one more step, and then I'll leave it to you for you to get in standard form. So we'll do one more step. Double negatives here, make this positive, and that's y plus 9 equals, and we're going to go ahead and multiply through. That's minus 18 over 11x. Double negative, when I distribute through, makes it positive. And 18 times that 6, that makes it 108 over 11. Now, I am not going to finish it from here, but let's talk about how you would finish it. Okay, what do we want our answer in? We want it in standard form. So how would I get this in standard form? Well, the first step would be multiply everything by 11, because that would clear your fractions. Then you would move that 18x over, and you'll end up with a 99 on the left. That'll go over as well to join the 108, and then that will get your answer then in standard form. So multiply everything by 11.
Including the y plus 9.
Yep, everything by 11. So that would give you then 11y plus that 99. And that's going to equal a minus 18x plus 108. You move that 99 over, move that 18x over, and that's going to give you then your final answer. So multiply it by 11. All the parts. Move the x over. Move that. You'll end up with a 99. Move that 99 over. And that'll finish it out. Question 7. Okay, now question 7 is very, very easy to do. Because question 7, we want it in slope-intercept form. And what you have is you have m equals minus 4/3, and you have a y-intercept, which is 0, 26/3. Now, we want this in slope-intercept form. So let's write out what slope-intercept form is. Well, slope-intercept is y equals mx plus b, and that b, remember, is your y-intercept, which is 0, b. Okay, now we have all the pieces already. We're just basically working backwards. Just like question 2 that we did earlier, where we had to, well, it wasn't 2, it was 3. Remember where we had to find the slope and the y-intercept. Now we're working backwards. So I'm giving you the slope, and I'm giving you the y-intercept, and we want the equation. So what would it look like if I rewrote it? Well, this is going to be your b. We've got our m, so it would be then y equals a minus 4/3 x, because that's your m, and then a plus 26/3, because that is your b. And that is your answer now in slope-intercept form. And the reason why we could do that so quickly is the fact that is a y-intercept. If it was a different point, we would have to use point slope. That's your y-intercept, so we can just use that directly with the formula. Okay, so that takes care of question 7. Next, we'll look at question 10. So we've got a couple more. And same thing on question 10. I'm going to get you to one of the last steps, and you'll have to finish it on your own. So question 10, we have minus 3, 8, and we want it to be perpendicular to minus 3x plus 4y equals a minus 23. Okay, so this one is going to, again, require us to use a flowchart. When we use these charts, we think about what we have. What do we have? We have a point, and we have a line equation. So that means we've got to use the last page. And you can use this flowchart on your exam. So don't worry about having to memorize things, because you can use this in addition to your notes. So let's now look at our flow chart, and we want to find the equation of a line, and we're given a point and another line equation. So what's the first step? Well, we take that equation, we solve that equation for y to get the slope. So first thing we do is we solve for y. So minus 3x plus 4y equals a minus 23. Well, we add that 3x over. So 4y equals now 3x minus 23. Divide by your 4. And let's see what we've got. So we now have y equals 3/4 x minus 23 over 4. And that is going to be the slope. But that's not what we want, though, is it? Because that's the slope that we got from the equation. But what do we want? Okay, if we go back and look, we want the perpendicular slope, right? So we go back again to our flow chart. So we solved it for y and we got our slope. Now, we're going to have to go down the left-hand side, which is the perpendicular side. So what does it say that we need for that slope to be? We need the negative reciprocals, opposite reciprocal, opposite signs, flip the fraction over. So that means we're going to have to use the perpendicular slope, which is going to be m, is then going to be, flip it over, 4/3, change the sign. So we're going to have to be using what? Yep, -4/3. So be careful with that part. Okay, so we've gotten to there. Now what are we going to do? Okay, now we go to the next step, which for the next step, we need to use our point slope formula. And what do we have? We have that point, which is -3/8, and we have a slope of -4/3. Write up our formula. Y minus y1 equals m times x minus x1. There's x1, there's y1. Fill the pieces in. Watch out for double negatives, because that's where we'll make a mistake at, or simple algebra. So y minus, it looks like 8 equals -4/3 times x minus, watch your double negatives again, that -3. So I'll do one more step, and then I'll leave the last step for you. So what have we done so far? We took our equation, we solved it for y. Okay? That gave us our slope. We didn't want that slope. We wanted the perpendicular slope. So we flipped the fraction over, right? And we changed our signs. So this right here is the slope we're going to be using, not the original one. We have to use that one. Now, what do we have? Double negatives here. So we'll go ahead and cancel those out. That's going to make that positive. And that's going to be y minus 8 equals 4/3 x when we distribute through. And what's going to happen on that last piece? Well, if you struggle with multiplying, write it out. So that's going to be a -4/3 times a 3/1. And what happens with the 3's? Cancel. So what's going to be left over? -4. Now, all you have to do to finish this out is one step. Because on question 10, we want it in slope-intercept form. So what do you need to do to finish it out? Just simply move that what over? Move that 8 over. Okay, so you can finish it. I want to at least leave something for you to do, but it's one step. Move that 8 over, and it's done. Okay, we got 2 more to look at, which is 12 and 13. A 12 is a difficult one. 13 is not, and 13 is going to be something that you're going to see on your exam. 12 is a more difficult question, though. And I'll get you started on 12. We did one similar to it last week, or not last week, the week before. But we'll get you started on this one. I'm not going to finish this one out. I'll do about half of this one. And if you go back and look at your notes from before spring break, we did a very, very similar question. Now, what do we have? Okay, we got a lot of fractions here, but what do we have when we look at it from that basic level? We have 2 points. So if we have 2 points, what do we use? We use the slope formula first, then we use point slope. So we're going to have to use the slope formula. And that is m equals y1 minus y2 over x1 minus your x2. x1, y1, and x2, y2. And you can't clear out the fractions until you have an equal. So we can't clear them up here. We don't have an equals yet. But when we use this slope formula, we have an equal. So that means we'll be able to clear out those fractions. So begin by plugging in the pieces. And that's going to be 5/4 minus 2/3 over 3/4 minus 1/3. Okay, is everyone okay with that so far? All right, we just plug the values in. Now, we can work with the fractions, but let's just go ahead and clear them out. That's going to be our easiest way to deal with these. What's my least common denominator? Well, I have a 3 and a 4, so the least common denominator is going to be a 12, isn't it? Okay, so multiply everything by a 12. So every single part in the numerator and the denominator gets multiplied by this 12. That's going to take care of all the fractions. And remember, when we clear out these fractions, what do? Divide by the number down below, multiply by the number on the top. So 12 divided by 4 is 3. 3 times the 5 makes it 15. Negative sign comes down. 12 divided by 3, that's 4. 4 times 2 makes it 8. Negative's already there. Down below, 12 divided by 4, that's a 3. 3 times 3 makes it 9. Negative comes down. 12 divided by 3, that's a 4. 4 times 1 stays at a 4. Now let's see what we've got. So now we've got 15 minus 8, which should be a 7. I always like to double check things because you don't want to make a mistake. So 7 in the numerator. In the denominator, 9 minus 4, that should be a 5, isn't it? Yep. Always like to double check things because you really don't want to accidentally make a mistake because of mental math. So don't ever hesitate to use a calculator to double check things. Now, what do we want? Well, now we have to use this slope because this is our m. We're going to use that slope with one of the points. Doesn't matter which one. Just use one of the points with that slope. So use the point slope formula. And we've got m equals now 7/5. And we're going to use that point 3/4, comma 5/4. And this is the most difficult question, I think, probably of this chapter, just because of the fractions. All the others are substantially easier. You're not going to see anything like this on your exam. So don't worry about seeing this. You're not going to see anything like this on your exam. It's good use of fractions, though. And we do use a lot of fractions. So we need to use our point slope formula, which is y minus y1 equals m times x minus x1. There's x1, there's y1. Plug our values in. So that's going to be now y minus 5/4 equals 7/5 times x minus that 3/4. I'm going to do one more step, and then I'll leave the rest for you to finish out. So I'm going to go ahead and distribute that 7/5 through, just to make sure we distribute it through correctly. Copying down the left-hand side, we have y minus now 5/4, so that stays there. Then we have a 7/5 x. And what do we do when we multiply through with this fraction? Numerators multiply, denominators multiply. So 7 times 3, that negative is going to come down with it. 7 times 3, well, that's going to be your 21. 5 times 4, that's a 20. So I am going to leave this for you to work with. How would you finish it out? Well, you want it in standard form. So you're going to have to multiply everything by a what? Can someone tell me? Multiply it by, what's my denominators here? 20, right? 20 would clear them all out, wouldn't it? Move it around and finish it. So multiply everything by a 20. That's going to clear all the fractions out. Then you move your x over to match up with the y. And that other number goes back to the right, whatever that comes out to be after you multiplied it by 20. So you're going to need to finish that. Question 13 is something that you're going to see on your exam. Question 13, you've got this point, 1/5, comma, 2/5, and we want it to be a vertical line. Now, there's two ways that we can look at this one. We can look at it and remember what a vertical line is. What's a vertical line? Vertical line is up and down, right? And that crosses the x-axis, so it would be an x-line. If you forget that, though, we'll just do it graphically. So you can either just remember that it's an x-line, or you can look at it graphically. So let's take a moment to think about this graphically. Let's plot our point. 1/5, comma, 2/5. Well, 1/5, 2/5, there's 1, and there's 1. We'll kind of make it a larger space here. So 1/5, comma, 2/5 is going to be about, right about there, let's say. Now, what kind of line are we looking for? We are looking for a vertical line, aren't we? Okay, so vertical line. Let's draw this vertical line here so we can visually see what our answer is going to be. There's our vertical line. Now remember, this is your x-axis here. Okay? Does this vertical line, does it ever touch the y-axis over here? No. What does it do? It touches the x-axis. Where does it touch the x-axis at? 1/5. So what would your answer then be? It's an x line, right? It's vertical, and it would be x equals 1/5, because that's where it crosses the x-axis at, right there. It crosses the x-axis right there at 1/5, comma 0. Never crosses the y-axis. It's a vertical line, so it's an x line. Now, if I would have said a horizontal line, it would look like this. It would cross the y-axis, and it would be y equals 2/5. So horizontal lines are y's, vertical lines are x's. If you forget that, do it graphically. So either remember, vertical is x, horizontal is y, or do it graphically quickly. So this one is just 1/5 there. Okay, I think that was the last of the questions out of 2.3. So now we're going to move on to 2.4. And this is going to be a much, much quicker, easier section. There's not much at all to 2.4. The next sections in this chapter are going to go pretty quickly. There's not much to them, and we'll probably finish them up today. May not get to 2.6, but we'll see. We'll at least get through 2.4 and 5. So let's now begin 2.4. In 2.4, we're going to be graphing inequalities. And when we graph inequalities in 2 dimensions, we have to first decide if we have a solid line or a dotted line. So greater than, less than, those are going to be represented with a dotted line. Greater than or equal to, less than or equal to, those are going to be represented with a solid line. So that's the first thing that we need to understand is, are we looking at a solid line or a dotted line? Okay? And then we're also going to have to shade, because remember, in inequalities, we have to shade the number line. But now we're looking in 2 dimensions, so we're going to have to shade part of the graph here. So let's just look at a couple of these. And we'll start with one that's mostly done for us. And we're going to learn how to graph y is less than minus 4x plus 3. So the first thing I want you to look at is I want you to first identify, is this a solid or a dotted line? Dotted line. Okay, so that's my first step, is determine what type of line. So we're going to be using a dotted line. Now, we're going to box this because we're going to come back to it later. But what we do is now we replace that inequality with an equal sign. And then we graph it. So we replace that with an equal sign, and then we can graph it. Okay, so how would we graph this? If it's got an equal sign, what would we do? Well, my slope is minus 4, and this 3, remember, is your y-intercept. So that's 0, 3. Okay, so where do we start at? 0, 3, so that's up 3 units. Now, what is my slope? It's negative 4, so I'm going to write that as negative 4 over 1. So that means we go down 4 units, and then we go over 1 unit. So we're going to go down 1, 2, 3, 4, and then forward 1 unit. So that's going to make it now at, if you count the units, 1, negative 1. Now, what's the difference between this and what we've done in 3-2? Well, sorry, in 2-3. In 2-3 and 2-2, when we graph these, we just connected them together and we were done. This one, though, has an extra step. So we already know from the very beginning that we're going to be using a dotted line. So instead of a solid line, we're going to connect these together with a dotted line. Now, we need to figure out where to shade. We're either going to shade above the line or below the line. So what we need to check is we need to check a point that is not on the line. And normally, the point that we pick is 0, 0. And we find 0, 0 and we locate it. And 0, 0 is right here and it's below the line. So we're going to check 0, 0 in the original. So check 0, 0 in the original. Okay, so we just plug our zeros in. And if I plug those zeros in, I end up with 0 is less than 3. And I'll slow down a bit so that we can get caught up here. So let's talk about what we did. We took our line inequality. Okay? We decided first off if we were going to use a solid or dotted line. So we decided, because of the inequality, because it was strictly less than, then we would use a dotted line. Then we replaced it with an equal sign, and we graphed it. Now, with inequalities, you've got to do one more step. You've got to shade. We plugged in our 0, 0 back into the original, and we got this. Now, is 0 smaller than 3? Is that going to be true or false? Is 0 smaller than 3? Well, 0 is smaller than 3, so this is going to be true. What that means is 0, 0 is true. And the other half is false. The line divides. So 1/2 is true, 1/2 is false. In this case, 0, 0 is true. There's my 0, 0. 0, 0 is below the line. 0, 0 was true. So now we can shade it. And where do we shade? We shade the true half. And where is it true? It's true below the line. So that is what your graph will look like. So you're going to shade below the line because 0, 0 was below the line and 0, 0 was true. Okay, let's try another one. I'll leave this graph up here for a second. Okay, so there's our graph in the previous one. Okay, now let's look at the next one. We're going to repeat the same procedure that we did the last one. This one's got an extra step, though. So, first thing we want to do is we want to figure out, are we going to use a solid or dotted line? Yep, we look at it. We have an equal bar here, so that means we're going to use a solid line. If there's no equal bar like the previous one, then we use a dotted line. So we're going to use a solid line. And next, we replace the inequality with an equal sign. And I always like to box the original so we don't lose it. It's so easy to misplace things. So I'm just going to go ahead and box that original. That's what I usually do, is box the original inequality because we're going to be using it later on. So we replace that inequality with an equal sign, and now we're going to graph it. So to graph it, we need to get it in slope-intercept form. So go ahead and add that 5x over. Right, we've got to solve it for y. So 3y equals now 5x plus 6. Divide by your 3. And we now have y equals 5/3 x plus 2. Remember how we used to graph these. Also, when you're working in this chapter, if you come to a question and you don't know what to do, solve it for y, because that is going to take care of most of the questions. Most of the questions somehow are going to have you solve it for y. So if you come to a question and you really don't know what to do, solve it for y. That'll usually get you started in the right direction. What's my slope? Well, my slope is 5/3. What's the y-intercept? 0, 2. Okay, 0, 2. So that's up 2 right here. There it is. What's my slope? 5/3. So up and over. So up 5 units. So we're at 2. So we're going to go 3, 4, 5, 6, 7, right? 5 units up. 3 units over. And if you want to, you can label that new point. Right? That new point would be 5 units up. It was at 2, so that makes it up 7. And that's your y component. And how many units did you go over? 3. So my second point there is going to be at 3, 7. Now you don't have to label it. If you just want to draw your arrows and put a dot, you can do that. A lot of times, though, just to make it easier for you to see, I label it. But you don't have to label it. A lot of times, though, I do. Now, we talked about it a moment ago, and we are going to have to use a solid line. So we'll go ahead and put that solid line on here. And we are not done yet. So we are not done. We still have to check. We've got that. We need to check 0, 0. 0, 0 is right there. Okay? 0, 0 is clearly below the graph. So you have to pick a point that is not on that green line. And the easiest point to usually pick is 0, 0. So we're now going to use and check 0, 0. Now, I'm going to try to put it this way it's on the same page. So I'm going to go ahead and check 0, 0. I think I'll just try to check it down here. So let's check 0, 0 back in the original. So that's minus 5 times 0 plus 3 times 0 is less than or equal to 6. Is 0 smaller than 6? Is that true or is that false? Is 0 smaller than 6? Yep, because remember it's opening towards the larger number, points towards the smaller one. So this would be true. Now, where's 0, 0 at? 0, 0 is below the line. So that means that half is true. The other half is going to be what? False, right? Always splits it. And where do we shade? We always shade the true half. So we're going to be shading the bottom half right here. Try not to cover everything up, but you're going to be shading all of this, right? So that's what your answer will look like. It's just shaded there. I just didn't want to cover up all the numbers, but you understand that it's all of it down below. Why is it shaded down below? Because 0, 0 happens to be down below the line, and also 0, 0 was what? True. If 0, 0 was false, we would shade where? The top, right? So if that half would have been true, we'd shade above, and it would not shade below. Let's do a couple more, and then we'll take a short break. So this one's going to be even easier than the last one. First off, solid or dotted line. Looks like we're going to be using a dotted line. And we replace that with an equals. And how would you graph y equals 4? Does anyone remember? Well, okay. When we go to graph this, what do we know? What do we have? We have a y line. Remember, there's 3 different types. Vertical, horizontal, or diagonal. Diagonal is when we have both the x and the y. We don't have that. All we have is the y part. So we find where y is 4. And this is your y-axis here. And y is 4 is right here. Okay? And you already told me that we're going to use a dotted line. So we're going to use a dotted line. And we're going to be on the y-axis because it's a y line. X line would be on the x-axis and it would be vertical. This one is horizontal. Now, what are we going to check? 0, 0 again. 0, 0 is clearly down below. And we're going to check that in y is less than 4. Is 0 less than 4? Yep, 0 is smaller than 4. So again, this would be true. That means this half is true. This half would be false. And where do we shade? The true half. And where does it happen to be true? Down below. So there's not a lot to do on these. Let's do an X line, and then we'll take a short break. And we'll come back and just do a couple questions to finish up this section, and move on to 2.5. Let me leave that so you can see it. Okay, so let's try another one. Let's try to graph now. X is, how about greater than or equal to negative 3? So what do we know? Well, we know we're going to use a solid line. So that's our first step. Always make note of that first. We're looking at x equals 3. And what would that look like if it's an x line? Here's our x-axis. Sorry, negative 3. Yep, I wrote it down wrong. Should be x equals a negative 3. Here's our x-axis. So that means we've got to go back 3 units. All we have is the x part. So if all you have is the x part, then that means it's going to be a vertical line. And we can now pick a point that's not on there. In this case, 0, 0. After break, we'll do some where you can't use 0, 0, where you have to use a different point. But this one we can use 0, 0 because it's not on that line. And we just replace that x with 0. And is 0 going to be bigger than a negative 3? Is 0 bigger than a negative 3? Yep, it is true. They're not always true. They can be true or false. In this case, we picked a lot of them that happen to be true, but they're not always true. It's about 50-50. It just happens to be that I picked a lot of them that were true, but half the time it's true, half the time it's about false. So 0, 0 is true. The line splits. So 0, 0 is true. That means we're going to have to shade back to the right, aren't we? So it's going to look like this. So that's what your graph will look like. Okay. Let's take a short break, and let's meet back here at, how about 9:40? We'll come back and do a couple more questions to finish up this section and work on the next one.